Okay, let's get started. Um, Thank you, everybody, for joining us today. Um, yeah, really excited to be here and talking about this, the Building Explorer modeling tool. We've been trying to find like the right name, I think, for this because when you get into energy modeling, like what you call things matters a lot. But yeah, so with myself here today, we have Adrian Brookson with Volta Research. Yeah, and myself, Juan Monterrosa with ENBIX, and we will get started. So as we get started with all the work that we do at Alberta EcoTrust, we like to start with um, speaking to like where we work across Alberta and recognizing the traditional territory and the many diverse Indigenous peoples that we work with. This includes the Treaty 6, 7, and 8 nations, the Blackfoot Confederacy, comprising of the Siksika, Kainai, Piikani First Nations, the Cree, Dene, Nakota Sioux, Saulteaux, and the Métis Nation of Alberta. These lands have been stewarded by Indigenous peoples for millennia who have maintained a deep and enduring connection to this land and its resources. So we honor their histories, their languages, cultures, and recognize the significant contributions that they've made to continue to make this region. So as you know, as Alberta EcoTrust, we carry our work across Alberta. We commit to respecting and upholding the values, the traditions of the Indigenous communities who have lived and continue to live here. For those that may not be as familiar with ENBIX or Alberta EcoTrust, Alberta EcoTrust is a foundation, is a trusted leader in advancing environmental and climate solutions across Alberta. We collaborate with diverse partners from government, industry, nonprofits, Indigenous communities to create a future where both people and nature thrive. So since 1991, Alberta EcoTrust has mobilized resources, delivered innovative programs, and supported impactful projects that protect and restore natural ecosystems, reduce greenhouse gases, and build community resilience. We offer a suite of programs, grants, investments, and strategic engagement initiatives that align with our focus areas, which are climate resilience and emission reduction, nature-based solutions and conservation, and the circular economy. ENBIX, which is bringing this webinar to you today, is funded by multiple organizations, so the City of Edmonton, Calgary, the Government of Canada, LC3 Network, FCM, Peter Gilligan Foundation, and RBC. And you can see there's the Shaping the Exchange. So the November 2023, so 2 years now of ENBIX, and Shaping the Exchange is what guides our work. Listening to what industry was looking for, and when we started talking about accelerating to emission neutral buildings, what ENBIX needed to provide. So out of that comes our training, tools, case studies, providing connections. A big part of this is really listening and continuing to listen. So obviously we did a lot of that work 2 years ago, but as we're going through and there's new challenges that are coming up through construction and design, trying to find what some of those gaps or barriers may be, and helping break some of those down. And a big part of our work at ENBIX is really having that Alberta lens. It's kind of like what we like to call it. Hearing what's happening across the country and how that aligns with the work here and with our grid and with our climate and construction practices. And providing, again, those solutions and tools and resources to industry here. So for today, kind of already a bit of an intro there. We're going to talk a bit about, what the tool is and why we created it. Some data from Alberta, from another project that we're working through with our Code Accelerator Fund. We're going to go through the demo of the tool, which is, I'm hoping that's why everybody is here today. Hear a little bit more about Volta Research and their work, and have some time for some Q&A. We will be just taking questions kind of as we go through. I'll probably have about 2 or 3 kind of different spots where we can check some of those questions. So if you have any questions, please put them in the chat. We'll be using that just to track those. I have somebody else, Alicia, on our team who's going to be looking through those. So we'll get through those. If you have any as we go through, please put them through the chat, and we will address them as we go. So as I mentioned, we have Aiden here and myself that'll be going through the work, and I see Lee is here as well with Volta Research. So the what and why, again, to me, it's like it's looking at that shaping the exchange has been a big part of like what directs our work and guides our work. And what we keep hearing is, what kind of tools are out there that can help us get to higher levels of energy performance. So you're going to be hearing me saying high performance, emission neutral, and all that kind of like within the background of codes as well, and the tiered codes. And we have a new one that just came out. It was a nice little pre-Christmas present for everybody. So I'll probably just be touching a little bit on that, but we probably won't go into too much detail today on it. The other part of it is, again, with that code background, is looking at the prescriptive route versus the performance route. And like what are some of the resources that are out there or some that are needed to be able to, I guess, have more in-depth conversations when you're getting to higher levels of energy efficiency. So a table that I pulled out of some of the work that Build Alberta has done is just showing the tiers. So this is out of the code, and looking at the performance compliance path. Obviously, there's a prescriptive compliance path, which is also tiered. Again, some changes, I think, coming into that with the new code. Currently in Alberta, there's up to the tier 2. And so essentially, it allows us to have the I guess like the foundation of how we speak to higher levels of performance. And when we speak to code, I think something that we hear a lot of is, like, is there something, some sort of system that everybody can speak the same terminology when it comes to performance? And the easiest place to start for me is thinking about, okay, well, we have a code, so how can we start with that? And obviously the code is evolving into things, and we're looking at energy efficiency, but also emissions reduction as well. Today, we are going to be looking at the energy efficiency improvement, but also there's a bit of that piece there of GHGs, which Aiden will touch on a bit in the tool. So who's it intended for? This question has come up a lot since we launched. So the model launched in late November. And as we were doing a few presentations over the last quarter, people even ask like, who can use this? And, is this something that is for the general public, or is this more industry based, and who in industry would be using it? When we first started this project, which has been a year ago now, it was really to focus on builders and their design teams, and even some of the trades as well. And the intent really is to look at those that are maybe building prescriptive right now and are considering building through the performance route, or some of those that are building through the performance route and are meeting tier 1, and wanted to start, maybe they are tier curious and they want to start seeing what it takes to get to other levels of energy efficiency through the building code tiers. And again, through all that is like reducing the barriers in that performance path and provide those resources to have conversations with, if they're already working with an energy advisor, like they started looking at what some of the different options are, and like, can they look at, I guess like a more detailed calculation of what it takes to get to the higher tiers. Also with conversation with the trade. So like, somebody has decided that they want to do a double stud wall because it's part of like the model. What does that mean when they're talking with their trades, in terms of the constructability of that, and also the cost, and also to have conversations with suppliers if they're seeing that they're, if they want to achieve a higher tier with possibly different equipment. So what it is it's a high level parametric model is what we're looking at. As I mentioned, we were looking at this a year ago. There are some models that exist out there that are these high level parametric models, and you're seeing more and more of those. And I think we'll hear a bit about that from the Volta team of how that can help look at all the different options when it comes to energy modeling and what it takes to get to those higher levels of energy efficiency. It allows to have different building characteristics, and all this like going at building envelope, mechanical systems, and then seeing what the outcome is with the energy and the GHG, but also looking at it kind of, if you want to start at tier 2 or a higher level of energy performance, what does that look like in terms of design and comparing what you have already. Yeah, and it provides an opportunity for optimizing with cost for construction. Some of these tools that are out there have already a kind of like an embedded cost in there, so you could look at balancing, the cost for tier. And as you'll see, like we've kind of allowed a place for each builder to implement or to input that data. This data and like the inputs that we were looking at was based a lot on what we're seeing that's already being built in Alberta, along with some of the resources that we have also on the ENBIX website. So we've been working with the city of Edmonton, the city of Calgary, the town of Canmore, and we're currently trying to bring in more municipalities to get data, permitting data, and looking at the HOT 2000 models, and essentially looking at, at each of the tiers, what are the characteristics for those models, and how are they getting there, whether it's through envelope or if it's through the mechanical systems, and using that information that we gathered to help out with the Volta Research team to build this model out. So I'm gonna stop there. That's essentially like the what and the why, and I'll stop there if there's any questions yet. Pause.
Okay.
Okay.
I'm just gonna take over the screen. Um, Wait, yep. Oh, there we go. Okay, so before I get started, were there any questions you wanted to field?
None yet.
Okay. So hello everybody. I'm Aidan Brookson, the research director at Volta Research. A quick background on who we are before I get into the demo of the tool. Volta is a nonprofit that works across Canada in the residential building space, and we do research and software development in everything that sort of relates to the residential building space. So that can be on the building science side of things, all the way up to, let's say, the smart grid that attaches to the building of the future. Or we do sort of electric vehicle research as well. Most of you, if you're familiar with us on this call today, you're probably familiar with our work on the Volta Snap platform, which helps energy advisors do energy modeling with, HOT 2000 and CSA F280 and so on. So now, with that intro, I'm going to dive into, let me just make sure my screens are all here. Okay, dive into a demo of the tool. I move this. Do you see that? Okay, it's fine. So here is the tool, the Builder Explorer modeling tool. We haven't yet attached it to our either ours or ENBIX's domains, which is why you've got this kind of default info here. But this URL is how you'd access the tool. Eventually, our websites, both Volta's and ENBIX's, will redirect here with our own unique URLs. But this will work for the time being and in the future. So it's essentially comprised of 2 pages. The first is the input page, where we decide, we sort of specify some high level details about the house we're looking to consider. So there are 5 input parameters. I'll just go through each of them and what our different options are. And these help us. Essentially, what they're doing is helping us choose and construct an archetype house in the background. And from there, we take that archetype and mix and match a bunch of different energy conservation measures, ECMs, on that archetype to see the potential impact on its performance, a number of different performance metrics. So the first, one of the most critical pieces of information to specify is the type of house we're dealing with. We've got two detached options and two attached options. They're both end units. The first is single detached. The first two are single detached, and they're both nearly the same. They're both approximately 2,000 square feet. And the difference between these two is that the second one here has an attached garage. So from a modeling or sort of archetype perspective, what that really means is that a portion of the first story wall of this house here is going to be adjacent to a garage, which is like a buffered space. And on the second story of the house, there is going to be an exposed floor above that garage. Which is, so in this example, we don't have that exposed floor. So there's nothing really there's no exposed floor components to insulate, whereas in this one, we do have that. Similarly, for the duplex row end units, the difference between these two is the same. This one here has an attached garage, and this one doesn't. If the garage is detached, it doesn't contribute to the energy performance of the house. So that's why we say it may or may not have a detached garage, because whether or not it has one, it's not going to contribute to its performance. After that, we specify whether the home has a basement or a slab on grade foundation. And that's going to mix and match with each of these selections up here and define the overall heated floor area of the building. So for the 2,000 square foot home, I believe the basement is 850-ish square feet. And for the duplex, it's around 600 square feet. And with a slab on grade, there's no extra floor area that's added to the house. Then we pick our climate zone, so where we're planning to build. And this does impact some of the minimum code requirements, but other than that, it's pretty self-explanatory climate zone. And then the last two sort of archetype selection parameters allow us to modify the window to wall ratio. So all of the archetypes, no matter the selections you've made up above, have had their window to wall ratios sort of adjusted to be approximately 15%. Technically, I think it's 14.7 based on some median statistics for new construction in Alberta. And then these two parameters let us adjust the window to wall ratio on either independently, the front face of the house or the rear face of the house. And you can pick average, which is that 14.7%, or you can pick to increase the window to wall ratio on either of those faces, which increases the glazing area on that face by 30%. So not to 30%, but by 30%. And so those are the key selection parameters. Pretty simple, but this amounts to a total of 128 different archetypes that are in the background here that we've constructed to make this work. So once you're happy with your selection, I can go ahead and click next, and we're going to load the archetype data in the background. And what you're seeing here, we've got a quick summary of those selections I made. What you're seeing here, there's what's called a parallel coordinates graph, as well as a table that has the underlying data behind the graph, that shows us the performance results of, it's about 25,000, a little less, individual sort of combinations of different upgrade measures on that house and the resulting energy savings, heat loss reduction, estimated emissions, and then the potential to include capital cost. So I'll go through the measures that we've included, and I think the easiest way to do that might be to look at them all in a list here. So I can click here um, to edit or input costing data. So for every sort of category of the home, which are represented by the vertical axes here, um, all the different options are listed here. And by default, we've got no costing data by default, but you can enter it, and I'll show you what that looks like in a second. I just want to scroll through so you can see all the different options. But then what's kind of, I guess it's worth demonstrating how this graph actually works. So this graph lets us select along the various axes to essentially filter out things that we don't want to consider. So say as a builder, I know that I'm not going to do an R70 in the attic. I might not want to consider these two wall options here. I can click on the sort of axis on the graph here and click and drag and select the options I'm willing to consider. I can click here to double click to clear those selections. I don't think this one had an exposed floor, so that shouldn't matter. Maybe I only want to see these windows. I'll do any air tightness. Maybe, for example, I want to only look at all electric options, and maybe I don't want a heat pump water heater. So it lets me sort of go through, make selections, filter things out. And then it shows me the estimated energy savings performance, heat loss reduction, and emissions. This is the absolute value of the emissions, not yet aligned with I guess the 2025 operational emissions emission factors. And then what you can do is scroll down here, and so based on these selections here, I've essentially filtered it down to 24 different options. I can scroll through the table, see what those exact specs are, what the exact energy savings are, and so on. I can also export all of this data. Where'd it go? Here it is, as a CSV. And then you can kind of filter 23,000. Filter, and, do your own analysis offline with it, and so on. Another way to kind of approach the, let's say, filtering of the data is, let's say I have a given performance tier in mind. So I'm going to say I want between 20 and 40% savings, which I need above, I think it's between 10 and 20% heat loss reduction. And then this is going to show me the options. So the 42 options that are going to achieve performance within those ranges. But where this really becomes valuable and fun and interesting is when we include costing data. So this, I've pre-populated some costing data for certain components. You can enter by square footage of that component itself. Others, it's overall. And you can so we've got nothing here for the exposed floor because this option is the same one. It doesn't have an exposed floor, so the costing here doesn't matter. But you can either enter cost data as the sort of absolute cost value, which is what you'd see done here, or as an incremental cost, which is what you'd see here, because we're saying that, achieving 2.5 ACH, that's our baseline. So that costs us $0 to get to 2. It's an extra 800 on top of that, 1.5, 2100, etc. So as long as within a given category, all of your costs are all either incremental or absolute. It works, and then they can kind of mix and match between categories as long as within one category they're defined as either all incremental or all absolute. So now what we can do is I can take those performance thresholds. So say I want within here and here, and I can say I want only the lowest cost options that fit or that hit these targets. And I want the lowest cost options that give me the best emission savings, because why not? The costs are essentially the same. And then that filtered us down. Oh, I was reading page numbers before. I guess this is one pages of 25. So there's 42 pages here. um, so then these give us all of our options that allow us to hit these ranges of performance that I've specified. And I can click to clear these selections. If I want to sort of increase our performance, we want to go to tier 5. Oh, yeah, that heat loss one right at the top. Might as well get the most emissions while we're here, lowest cost option. And then here they are. So obviously, we've got kind of the most, what do I want to say, intense ECMs that get us to essentially the top of the tiers. I've already shown the ability to edit costs. So what you can do too is like I can go in and change these, and it'll modify these numbers here. Clear that selection. Edit costs. When we go down here, we've got some instructions. If you're watching this webinar, you know all the instructions. And then we've got some modeling assumptions here. So some things that there's obviously a lot more to the model than what are written in these quick high-level labels. So some of those things where relevant are described here. So for example, the hybrid air source heat pump uses a switchover of -10. Here's the insulation used on the foundation, because that's not a measure that's it's changeable. Front-facing orientation, and just information about how the energy savings percentages are calculated and so on. Clear selection. Exported the CSV. So then one more thing we can do is save and connect. So what I can do is type in my email address. If I had selected a package, this would be populated here. Actually, maybe let's try that to demonstrate. We're going to assume that works. So yeah, when I've selected something here, it kind of highlights through the graph. So I've got that package selected and I want it to be saved. And those are all the specs there. So I can type my email in. It'll save the costing data as well. And then you can choose to optionally share anonymized costing data. I mean, all this information other than your contact email is anonymized. There's no personal information entered or stored. But you can opt in to share your costing data. And we provide a way to indicate sort of how detailed that costing data is, just a qualitative assessment of the level of accuracy of the costing data. Whether or not it's a detailed quote or high-level estimate, we think it's still a valuable, contributing costing data to the sort of industry at large to help inform decisions by other builders, other EAs, researchers, etc. Good costing data and a breadth of costing data is hard to come by. So we're trying to figure out and create different avenues towards collecting anonymized costing data so that, we can provide a bit of, we can help assess, figure out, what the lowest cost pathways to achieve a given goal is. So this is going, when I click send, it's going to say sending and sent. And then what this did is it sent me an email, and with a link that's essentially like the same link that's here. Although I will say that right before this webinar, I was running some tests and found a bug with opening the link in the email. So that might not work right now, but I've got a fix for it ready to go. I just didn't want to push it right before a webinar because that's a big no-no. But it's worth noting that if you do this now, click save, and get the email and the link doesn't open, the act of saving did still work. It's just the link that like opening via the link that's causing an issue. So saving will still work and the link will work once our fix is live. So you can still save and that's all good. So that was, yeah. And eventually the idea is, with, where was I? I guess over here. With enough, we started this, we start this with empty costs because we didn't want to sort of make any claims about costs that, a builder looks at this, they say, those aren't my costs, so it's irrelevant. But, given enough sort of submissions, if enough spread, I guess, in the data, we might be able to derive some defaults here that could be useful and interesting for industry. So I think that might be a summary of how to use the tool. I think I've gone through all the features. It's pretty easy to use. You can, let's say I go here, I can just go back, change my specs, click next. It takes about 5 seconds to load that archetype data. And here I've got some new data to play with. I mean, at first glance, it looks similar, but it's all for this house here. Yeah, I might pause there and see if there's any questions, any things that like people want. I guess I'll demonstrate actually inputting costs from scratch. So let me just get a ball from like 6.
Take a look to see if there's any questions. If there's any questions, feel free to pop them in the chat as we're going through and putting in some costs.
So these are, dollar per square foot, so I can hit apply. And now you'll see there's kind of these discrete buckets because I've only input costs for the walls, which is totally fine. It's just going to treat everything that's not a wall as equal. And actually, it's worth highlighting here that, let me just get sure I've got a good ballpark. Okay. If I only input costs for a subset, so let's say here and not the third option, we're only going to display measures for which costs are provided within a given category, because otherwise, well, this would have 0. It would be getting a crazy cost credit that's not really real. It's just a result of a lack of information. So I can hit apply, and then you can see the lines that were connected up here to R70 have disappeared. So we're essentially filtering those out for the user because they're not it would be, I guess, a skewing of the results. Yeah. So yeah, while I spoke there, were there any questions?
Nothing yet.
Nothing yet. Okay. Yeah, it's pretty easy to use. So I guess like I'd encourage people to try it out for yourself. You can go click through. Oh, and I'll say that one thing that we've that is not yet deployed is the ability to open the file, the underlying file in Volta Snap, but that's coming soon. And then what you could do as a builder is connect that with your EA. They could open the file and like play around with these different options and get more custom than the sort of high level archetype analysis. Um,
Was one question here, Aiden, do the
mhm.
costs have to be input by the user every time, or are the costs added at crowdsourcing and remain in the software?
When you save your like data, the cost info is saved with it. So when that provides you with the link that goes to your email, it'll bring you back to this page to reopen it with all that cost information um, already here. But you don't get like other people's cost info by default. That would be kind of an offline analysis that ENBIX or us and ENBIX might do to look at the quality, the amount of costing data, and see if we can derive averages, medians, etc.
Thanks. Okay.
um, oh, go ahead.
Oh no, that's just it. I said that was great. I think it's um, some of the questions, I guess to me it always goes back to that cost. And I think the
Mhm.
decision around that was really, and you kind of alluded to it, was having those costs there. I feel like, well, one, I think they're changing every quarter now. So like
Yeah.
having something there, um it's hard to say that
Mhm.
that is what it's going to be again, like a year from now or something. So being able to have that ability for whoever's using this to put in those costs
Mhm.
um allows it to be specifically for that,
Mhm.
like
Mhm.
that type of project, right?
Yeah. Yeah. The only other thing I realized is that on the CSV, there's a couple extra metrics that are hidden from the graph just because there's a lot of information already, which are the electricity consumption in kilowatt hours per year, natural gas consumption in meter cube per year, and the annual energy consumption in gigajoules, which are just sort of other common metrics that people often um, look to. Yeah, so I guess with that, I can move on through the slides or
Yeah.
anything else you want to. Okay.
Let me see if there's any more questions at the end.
All right. Okay, so yeah, I'm just gonna talk pretty quickly about some of Volta's other projects. The first, um, the first big one, which is potentially how, if you've heard of us on this call, it's probably through this, is our Volta Snap platform, which is a web-based energy modeling platform that works within and around the Hot 2000 and EnerGuide ecosystems. So it runs Hot 2000 in the background. It runs a bunch of other side calculations alongside Hot 2000. The idea being to help, um, essentially help energy advisors with their day-to-day needs, also expand their tool belts to let them do um, more, let them do more kind of like detailed and insightful analyses without trying, without increasing the sort of time burden to do so. Um, yeah, so yeah, so in terms of what VoltaSnap can do, in addition to Hot 2000 simulations in a web browser in the cloud, it's verified to do CSA F280 heat loss and heat gain calculations, both on a whole home and room by room basis. Um, the whole home F280 heat loss is a very easy to uh, determine from the EA user perspective parameter. That because the data collection requirements around a whole home heat loss are very much in line with EnerGuide data collection requirements. So if you have a hot 2000 file, you can upload it, and after a couple clicks, get the whole home heat loss and heat gain. Room by room is a more recent kind of feature or addition to the platform we've added. Um, More municipalities and programs are requiring this, especially for new construction. It's a little bit more work on top of a typical ERS data collection procedure because you have to divvy the house up into individual rooms. But we've done a bunch of work in Volta Snap to try to make that process as easy as possible. Additionally, we do hourly electrical load estimates. We recently ran a series of webinars, presentations that have been showcasing the potential to use these and estimate, actual peak loads from houses, and we've seen, I think, maybe surprisingly good results. We also do sort of a side by side. We make it easy to compare different upgrade packages and create like a roadmap for your clients. So if that's a builder, you might show them different ECM packages or code packages compared to their design as designed and or as proposed packages. And you can compare a bunch of different options at once. Or if you're working in the existing building space, you can kind of build out a roadmap that may be like phases in time, or roadmaps that may diverge based on different goals, etc. You can also do parametric analyses, and if you work with an organization within an organization, there's some file sharing and like spec sharing capabilities within the platform as well. Coming soon, this is a big one at the top, our mobile app for data collection, which if your phone hardware has LiDAR room scanning built in. You do need an Apple or an iPhone Pro model to use this because that has the built-in LiDAR hardware. But if you do have that and are interested in beta testing our mobile app, you can reach out at the contact email provided here. We're looking for testers because it's ready to use. And then coming soon, all of these, the next 4 bullet points are going to be live in Volta Snap by the end of March, which is pretty quick. So embodied carbon decision-making assistance, integrating with costing databases, community parametric analysis, and running Energy Plus alongside Hot 2000. This opens a lot of doors, especially around resiliency. There are a lot of different, say, control levers around the simulations you can do in Energy Plus that let us look into some interesting attributes, aspects of the home that could impact decisions around planning for resiliency. In terms of some other projects that are not related to Volta Snap, we recently completed with the residential building focus a project with CMHC and Clean Foundation that looked at the development of retrofit plans for like a large number of homes. It was 200 homes for an affordable housing provider. This has gone on to inform the community analysis feature that I mentioned in the previous slide that is going to go out to all users of the platform shortly. With a distribution grid focus, I also mentioned the webinar series that we'd run recently, and I think there might be some case studies or something. I'm looking for a nod from Lee, a thumbs up. Yeah, there's going to be some case studies that come from that. So we looked at a number of 3 different builders in Ontario that built high performance homes with some degree of electrification. So one of them used a ground source heat pump, one used a ground source heat pump in some homes and hybrid air source heat pumps in others. Another built to net zero with air source heat pumps, and the third also built to net zero with air source heat pumps and actually quite a bit of solar. I think 30% of the homes had solar. And we compared different modeling practices, so Energy Plus, the hourly method in Volta Snap, to the real world data that came from these homes. And I think it showed promising results in terms of kind of EAs being able to use their code compliance models to assess more aspects of the building. So perhaps be able to um, estimate what something's impact on the peak load of a home or group of homes might be. Um, yeah. And then we actually do quite a lot of work with electric vehicles, specifically around vehicle to grid, so bidirectional charging technology, or V2G or V2X, vehicle to everything. We do a lot of work with a professor out of University of New Brunswick in this area, and have done a number of demonstration projects. And sort of feasibility studies in and around vehicle to grid technology. And so that's our project highlights. There's all our contact info. That QR code will take you to our website, which also has our contact info. And yeah, with that, I'll bring it to questions and sort of pass it back to, yeah.
Yeah, thanks a lot. Any questions? We go. I think it's like, I mean, looking at that work, and just like, conversations we've had in the past little bit, and the tool that we've created, like a big part of it, and it's kind of what, like, going back to even just like the costing or whatnot, it's um I find like that is the really, like, at the end of the day, like the main driver of how we're showing the most cost-effective path to getting to higher performance tiers. Even like ROI, I think that's one thing, kind of like the next thing to look at is, we talk about I guess, like the total cost of getting to high performance. And we, like, I don't know, like I think a lot of people on the call here is there is obviously that capital portion, but like we're still missing a big portion of like that operational bit at the end. And like how you're mentioning, you can see what the natural gas or like the electricity is. And although in the model it's high level, at least it allows people to start. You could do some calculations of like what the cost is. And with some of the builders that we've been talking to, it's, instead of, if you're not going to show the total ROI, it's like how much would you be saving then on your monthly bills, right? And I think that's kind of like
Mhm.
where the conversation is at least starting right now.
Mhm.
Yeah, and I think it's neat to see that, and along with, connections to Volta Snap and getting to like that more detailed analysis.
Mhm. Yeah. Yeah. Um,
Questions? Anybody want to unmute, or just you throw it in the chat? We have about 10 minutes left.
I guess I can open chat. The
Mm,
tool currently focuses. Uh, oh yes, that is the answer.
yeah.
Mhm.
Okay. It was probably just because you showed everything that needed to be shown, Aiden, right? So
Yeah,
it was very
it's
clear.
pretty easy to use. So yeah, just I mean, those on the call, don't hesitate to try it out again. Oh, what am I controlling?
Um,
I guess I could put this in the chat, I guess. I don't know if it's, I don't know if it was shared anywhere, but there it is.
yeah, I think it was at the beginning there.
Um,
I mean, and this is
yeah.
like, this has all been part of like, again, just trying to get more information out to industry of just what it looks like,
Mhm.
to like go and move a few inputs around to get a feel for, again, like what engineer, and like we always talk about buildings as a system, and to me it's being able to be hands-on and look at how it all interacts
Mhm.
is a great tool to have. I'm gonna selfishly plug our next initiative and project that's coming up that just opened up today. So it's the Getting to Zero research project. So we are paying for information for high performance buildings. So if anybody's familiar with some of the work that's happening in ZEBEX for their near zero program, very similar to it. Three different streams, one stream along like near zero, I guess, or like getting to zero buildings. So anything tier 4 and up, asking for detailed costing. And there's two detailed questionnaires, and along with like modeling that we're looking for. There's one around embodied carbon, and looking at how you could the cost again of getting to lower levels of embodied carbon through beam or MC squared modeling. And then the other one is heat pump installation. So looking at cold climate heat pumps, hybrid systems in Alberta, and essentially, yeah, paying for information on energy modeling and the F280 calculations across the board for at least stream 1 and stream 2 as well. So yeah, if anybody has any builders in Alberta that are interested, we just launched today. Well, with that, thank you very much, Aiden and Lee. Thanks
All right.
everybody for coming today.
Thank you. Thanks for having us. And yeah, thanks for coming.
Okay, talk to you later.